Hello everyone. I'm Amulya BR from Sri Venkateshwara College of Engineering and I belong to the branch CAC AI. So today I'm back with another video on the subject software engineering and project management and on the topic software engineering. So let us look into what we are going to learn today. The contents are overview of software engineering, software development lifecycle, types of software models, agile methodologies, software design features, software testing and quality assurance, software architecture, future trends in software engineering, and its conclusions. Now, let us see the overview of software engineering. So, software engineering is a systematic discipline approach to the design, development, testing, and maintenance of a software. So, this aims to produce high quality software which will meet the user requirements and it is reliable and maintainable also. So, the stages in development of software lifecycle is called software development lifecycle. So, this has various steps like requirement analysis, design, implementation, maintenance, and etc. So, tools such as CI/CD, that is in cloud or DevOps, will also be made use. So, the quality assurance and the testing will ensure that the software will meet the high standards through practices like code reviews. So, let us move on. We have the software development life cycle. So, software development life cycle is a structured process for creating high quality software. So, it contains the following steps: planning, design, implementation, testing, deployment, and maintenance. So, first let us see what is planning. So, gathering and analyzing the user needs to define the functional and non functional requirements is called planning. So it also uh, includes the design stage here. So design stage means creating the architectural and detailed design documents in order to plan the system structure and architecture. Then we have implementation phase where writing of the code and compiling will be done here. And then we have testing phase. So here we will verify the software whether it will meet the user requirements or not through various types of testing like integration testing or system testing, and there are a lot more. And then we have the deployment phase. So this deployment phase is nothing but releasing the software to the users and gaining the feedback from them. And then we have the maintenance stage. So this is nothing but updating and improving the software accordingly by including like bug fixes or enhancements or any other necessary adaptations to the environment which is required. So next we have types of software models. So there are various types of software models. So these models will guide the software development process. So it offers various approaches to ensure there is effective and efficient project completion. So the types of models will include waterfall model, V model, agile model, spiral model, and a lot more. So the main type of models which the industry will include in these days are the waterfall model, agile model, and spiral model. So these three are very important. So first is waterfall model. So waterfall model is a sequential and linear approach where the phases like design, implementation, testing, deployment, and maintenance. So be it in any of the software models, there are five main steps or the approaches or phases. So these five phases are nothing but requirement phase, design phase, implementation phase, testing phase, and deployment maintenance. So these five steps will always be there in any of the models. So the waterfall model must be completed before beginning of the next phase. So it is inflexible to changes basically. So next we have the agile model. So agile model is iterative and incremental approach. So this will emphasize on flexibility and frequent delivery of small and functional software increments. So popular framework will include Scrum, And then we have the spiral model. So spiral model will combine iterative development with the aspects of software, the waterfall model. So it combines both the iterative development as well as the waterfall model. So this will focus on the risk analysis and refinement through various sprints or spirals. Here we don't call it as sprint, we call it as spiral. So next up we have agile methodology. So now let us see what is agile methodology. So it is an iterative and incremental software, as I told earlier, and it is also collaborative, and it also includes customer feedback. So it will divide the project into small manageable units, which is called as sprint. So these small units will be typically lasting for 2 to 4 weeks. So sprint is for 2 to 4 weeks, and each sprint will deliver a functional software increment. So this will allow for continuous improvement and adoption. So Agile will it will promote a cross-functional team and stakeholders. That is, it will ensure that changing requirements are quickly addressed. So some of the popular Agile frameworks will include Scrum. So this Scrum will focus on regular progress reviews and adaptations. And we have Kanban. So this will visualize work progress in order to optimize the efficiency. So that is all about agile methodology. So next, moving on, we have the software design patterns. So what is a software design pattern? So it is nothing but reusable solution to the common problems in the software design. So it will already provide a template which is ready made for how to solve a problem in various contexts. So it will promote best practices and it will improve the code maintainability. So some of the design patterns will include like creational patterns, that is, it deals with object creation mechanisms, or it may also include structural patterns, that is, it will identify a simple way to realize the relationship between various entities that is present in this software model. And then we have the singleton, as I've mentioned here. So this ensures that a class will have only single instance. And then we have the observable or the observer. So this will allow objects to be changed or notified that they are dependent on. So moving on, we have the software testing and quality assurance. So what is software testing? So software testing is nothing but we need to check whether the software is meeting the requirements of the user that is specified earlier in the planning or the requirement collecting phase. So, software testing and quality assurance will ensure that there is software reliability, functionality, and performance is improved. So, testing will include various software, that is, it may include the unit testing, integration testing, performance testing, acceptance testing, and there are a lot more. So, here, unit testing is nothing but verifying the individual components whether they are working fine, and then acceptance testing is nothing but we need to check whether the model is meeting the user requirements and it is accepted by the user or not. So this is done by the acceptance testing. And then integration testing is nothing but we will ensure that the different components that we have made is working fine together. And then we have the performance testing. So in this testing, we will be evaluating the model's performance based on various parameters that has been decided earlier. So these are some of the important types of software testing. So next we have the software architecture. Software architecture is high level structure of software system. So this will define the components and their interactions. It will provide a blueprint basically for a system organization. So this will also guide the design and implementation. So this will ensure scalability, performance and maintainability also goes hand in hand. And then we have the types of software architecture, like for example, microservices, and then client server, and a lot more types. So the stakeholders will serve as a foundation for decision making throughout the development of software model. So the software architecture will design as such. So now moving on, let us see the future trends in software engineering. Future trends in software engineering will include the artificial intelligence. So, artificial intelligence and machine learning will enhance the automation and if there are any predictive analysis to be done. And then we have the serverless computing. So, this means the cloud based infrastructure, for example, DevOps and such practices will become more prevalent and it will improve the collaboration and delivery speed too. And then we have the blockchain technology, so that is be it the IoT. So it will drive the development of the distributed systems and it will be like no code platforms and it will democratize the software development. So moving on, we have come to the last phase, that is the conclusion. So software engineering is vital for developing high quality and reliable software. By applying such methodologies as we discussed earlier, so the best practices and emerging technologies will be made. So it ensures that the software will meet the user requirements as well as it will underpin the innovation and efficiency in various domains. I would like to thank each and everyone for watching the video completely till the end. I would also make sure to come back with another video on a different subject. Until then, have a good time. Thank you.